Hey everybody. It is Tuesday, January 16th, and is this our first community meeting after the new year?
It is. It's our
You bet.
It is.
2024. Here we go.
Welcome back, everybody.
Welcome.
Well, let's see, what are we up to? What's the audience count here?
We're getting there.
Getting there? All right.
Agenda.
Well, we usually go through a bit of netiquette at the beginning. Thanks for coming, everybody. My name is Nate Boot. I'm a developer advocate, and I'll hopefully be guiding everyone through our wonderful meeting today. We have two presenters, and they're gonna just rock your socks off totally. How was that? Awesome.
That worked.
We usually follow some etiquette for everyone. If you're new, please do introduce yourself before speaking. Please do mute yourself unless you're actively speaking. Cameras are, of course, optional. And please ask questions at any time in the chat or audio. I do ask, though, that if we have presenters and they have preferences that are stated, please do try to accommodate our presenters. We've also turned off a lot of access things to keep undesirables out. So there's no screen annotations. Profiles only show names, and only hosts or co-hosts can share their screen. And there's people around to kick other people out. No one gave me any announcements other than Happy New Year.
Happy New Year.
And does anyone have any announcements? Birthdays, anniversaries, work anniversaries?
We had a really good blog post going out recently about the continued performance progress that the OpenSearch project is making. I'll put a link to that blog post in the chat here so everyone can read that on their own time. But a lot of work went into that, and there's a lot of work went into our continued performance enhancements. So it's well worth a read.
Yeah. Pretty soon you should be seeing a recap on our AI progress this year as well.
Yeah, David,
over the last year.
Yeah, I was just going to point out, in case you all missed it, we've moved the release date or release window for 2.12. That has been officially ratified as happening between February 6th and February 20th. That is our next release window, just to accommodate some of the new stuff that we're hoping will come through Lucene here shortly. So
that would have been a rad announcement to put in here.
It would have. I wish I had thought about it before 2 seconds ago.
Same. I'm like, oh yeah, huh?
Oh.
All right. Well, feature discussion. Views, experimental release. Looks like Peter Need, you are up, sir.
Excellent. Hi, everybody. I'm a senior software developer from Amazon. I have been working on OpenSearch for a long time. I recognize the number of names in the audience there, so hello again. I wanted to talk about a feature that I'm kind of incubating, and I'm looking to get some thoughts as well as potentially help as we're building this out. I want to try approaching this a little bit more nascently and making sure we get some broader involvement compared to some of our other arrived, fully developed, and fully formed. So also in that same vein, this is arriving less fully developed and less fully formed. So please set your expectations accordingly. That said, I actually do have a fully operational prototype that I'm not really going to be demoing much because there isn't too much to demo. But let me talk about what I'm looking for in this space and where I think we'd like to go with some of our data access model in OpenSearch. So the big issue that I see, I often work in the security space, building out security features, and we seem to have these conflated scenarios where there's authoring and then there's a completely separate experience that's about like using the data. So we have lots of tools that are organized around like the location, the physical location of data. So this is like index names. That's a marker. It represents where we're storing data, how we organize and partition data using, let's say, like rolling index names, or say we use some of the other data types that are available, which I'm basing on right now. Data something. There's another system that we have in OpenSearch that kind of abstracts some of that. But we have this very loose abstraction to when you actually use data. So, for example, if you've got a product that you're offering a search box for, you have to know the organization model that was used to hold that data. You have to know the index names. You have to know like an index pattern sort of thing that you query. And that's one of the things I want to address with this new feature views. So it's a projected view system. So we dynamically query based on saved information. And one of the reasons why I wanted to kind of move in this route is I don't think many of our customers that are running queries are too interested in dynamically assembling the kinds of queries. I think they really want to make sure that they're using the right query or they're using the right data source to do the job. And so the notion of storing all that information in one spot and making it something that a data author can fill out then gives a consumer of that data something to access. And so that's one of the big differences that that I'm looking to make with this feature. If you look at the experience today and some of the other features that are available, we've got aliases, we have search templates. Those things still create. You still need to know information about the underlying data system. I don't know if other folks have run into this, but I've had to re-index data, and I re-indexed the data, and then I quickly had to re-index a second time to make sure that all of the queries would still line up. That's kind of an artificial problem because we're directly exposing how we access data to these downstream systems. And so that's something I'm hoping that we can take a stab at, and maybe we have a more direct access method that I think makes a lot more sense for data use case scenarios. Data stream. Thank you, Ryan. Are there any opinions about this? Does anyone think that this is a space that maybe isn't as interesting, or maybe there's something that could kind of supercharge this notion? Looking for a little audience participation.
I could really use an example. For one, I don't think I quite gotten to the bottom of your mind there.
Oh, sure. So, like some of the features we have in the security system is you can filter the kind of data that users can see. So you can say, I don't want the field social security numbers to be visible if you're querying this, customer data system. And the way we hide that information is very obfuscated. And what I think would make a lot more sense is if we had a view that said, like, look at the customer data, but it's the, the front end friendly version. So front end friendly customer data. Something in that regard where the way that data is shaped and how that data is accessed is completely independent from the person who's making the call. So in this case, you only need to know the name of that view. You don't need to know any of the underlying indexes or data structure. Does that help?
Yeah, that makes sense.
So
from this point of view, if you said, let's say social security numbers, and there was a field, if someone was odd enough to put a field in the box called social security numbers and just throw that data in there, you're saying rather than have to go into the index and change settings, then the person who were doing the filtering would have some form of user experience UX that helps them see, like, these are the fields in the customer's, these are all the fields, and just the same way we could like filter for a field, we could filter it out, and then we could also like filter it away, I guess, or something like that.
Well, yeah, that's I think a great example of this is actually part of the existing dashboards UX, which is a thing called index pattern. In the backend, which is mainly where I operate, there's no analog to index patterns. And to me, I think a index pattern is a great example of a view. And there's actually even a requirement in the way it's implemented in dashboards where it has a time field for that time series visualization. And I think that's a great, kind of like metadata associated with, that set of information that we should have a consistent way to refer to, and then also, access and edit. Because I think that's for like a user model, I think that's what users are really interested in. Like, give me the data shaped kind of as I expect. And with the way that OpenSearch encourages you to make big chunks of data, everything you need, since cross like joining isn't something we recommend. I think kind of using these like filtering approaches or metadata annotations is something that's really missing that would be useful to add.
Well, it sounds
It
cool.
sounds like an extension of like field-based access control or anything like that, but those restrictions would be defined within the view rather than within the field mapping.
Well, I wish the field mapping itself had that kind of restriction. Unfortunately, it's like an amalgamation of several of your own identities. I don't want to necessarily go into why I think that system deserves a replacement, but that's, to me, as a guy who primarily works on security, that's making that more understandable to users is really interesting to me. But yeah, exactly.
Cool.
I'm gonna step forward. I've got these, incredibly detailed slides. And kind of the other part to this is when we're talking about access control, the model that we have for access control using these like wildcard patterns typically, it's kind of hard to wrap your head around that those asterisks can actually make it easy for someone to permission something they didn't intend to. So if you happen to have to create a new index name that already encompassed another index name that had access control, availability with that wildcard, you could suddenly see something that you weren't expecting to see. That gives me the heebie-jeebies because I don't like the notion that when we're making decisions about access control, that we can make like simple mistakes, or it can be hard to audit those kinds of mistakes. So I don't really like the current nature we have for access control. And I think what I'd really like is if access control was based on this kind of like scenario-based workflow. So you get access to that limited customer view, say that doesn't expose social security numbers, but it has all the rest of the interesting information in there. I think by having that in one place, it makes auditing and understanding that much easier. It also means that how we can test and like be sure that the access control is working the way we expect. Like let's say if we were intentionally trying to filter away the social security numbers field, it would be really nice if you could double check that and be sure that that was working to your expectations, rather than being surprised if half the social security numbers are popping out for some reason. Or something else of that nature. The other part to this, and this is kind of how I arrived at this feature, is when we're computing access control rules in the security plugin, it's expensive, and we have to go to a very fine level of granularity for every single search, for every single field access that happens. And I think that dynamism is useful in some scenarios. But I think it's also a huge perf impact that isn't obvious. We don't have an obvious access to that or an obvious fix that also maintains having access control systems. So I'm definitely interested in kind of reframing a little bit how we grant access to different things, and then also how we can be sure what we have access to. and what that really means. Like, I'd love it if you have like a rolling uh, uh, index pattern. I'd love it if you actually said like, this is the year's month day field. And so you knew that if anything was breaking that pattern, it wasn't just going to show up, rather than the current case where we have just the wildcard symbol as an example of that. And this gets to kind of the last point, and this is the most interesting from kind of where we might be taking OpenSearch forward. So I'm talking about a new kind of information. We have we have the index patterns that we use, but we don't have too many other, or frankly, we don't have any other things that are really first-class citizens as far as like a resource model goes. Like, what are all the things I have access to? And part of building up this views system would be making sure that it's addressable in some way. How can I address a view to know, which one it is? And I think this also extends out to a ton of other things that plugins are doing. I look at ML models. I look at alerting monitors, or alerting notifications. We don't currently have an identifier space where we can declare what things are in a way that's consistent, so that we can also say you're permitted to see some things and you're not permitted to see other things. And maybe that lives in a unified list. I know we routinely on the security team get a question of, can you tell me what I have access to? And unfortunately, the answer is yes. Only it's 2 to the power of n runtime to determine what that is. So you better be willing to accept some fluctuations in your cluster stability to have that feature work. I'd love for us to actually be operating in a space where we don't have to have that kind of kludged together system, and we can really more concretely show what these things are, and also give you a definitive list as a user or as an administrator of what you have access to or don't have access to. And I know there's many folks that have filed feature requests that
So like
probably
you would,
be happy.
you're advocating for like a, sorry, what were you gonna say?
Oh no, go right ahead.
You're advocating for, like, today we have an index, and it's pointing to, that's the first class citizen. It's pointing to different charts, and that's where the data is. So are you advocating for like sort of saying, okay, we kind of ruined things by using the word index, but because indexes shouldn't be like the one, right? They shouldn't be a one-to-one to the data. There should be several. You could have several indices pointing to the same bits of data. They're just supposed to make it easier to access. You're saying like we could have linked to the actual documents. We could have a different form of like an index, so we would be able to create these on the fly.
Well, not just associated with index, but even whole other data types. So maybe an
like
example.
not an index,
Okay.
something else.
Oh yeah.
You wouldn't call it index. You call it, let's say we call it a view. It's like an index because it has shards and it has data. It's the same as an index. The thing is, it has this extra quirk that, like, when you were forming the view, it had this filtration done, so it's not actually seeing the same. It's not seeing the data the same way the index is seeing it when you search it. Am I correct in understanding?
Yeah, and I would even go one step further, which is we have many other things that aren't associated with indexed documents at all. Like we have security roles, or we have users, or we have nodes. How do you look up one of those? What's the way we identify those things? And the answer is usually you have to know, like where to paste that identifier into to get the right association. Maybe that's something we should be building up more so that we have we actually can know the space of what is out there, what you have access to or don't have access to.
I'm wondering if you're looking at the code, what's missing in terms of like best practices for making it more secure and enabling this. Like there's this very specific way that Elasticsearch was written in. It has a very clear and simple format of saying like everything's a task, all that kind of stuff. what are we
Well,
doing wrong here for
I
security purposes?
I don't know if I can say like unequivocally like, oh, this is what's wrong or this is what's right. But I think as this Lucene uh, network fabric evolved, um, the the idea of anything that wasn't those Lucene documents in some sort of in their storage medium, it just wasn't important. And as the plugin space, at least around like the plugins I commonly work with OpenSearch, like they have concepts that certainly leverage those documents, and maybe their storage medium is actually those documents, but they logically represent something different that should have like its own verbs to be accessed or modified. So like I think task is actually a great example there. I think knowing the tasks that are out there and maybe knowing what tasks you have the ability to cancel or not, like what task you have administrator privileges over, might be a good thing. It might be some way to codify that. But I don't know if task is the right thing, because I know today they're pretty ephemeral. I don't know if it would make sense to have some permissioning there, but maybe there's something to be said to that, or maybe it's about like the pool that the tasks run on or something of that nature. How does that sound?
I mean, yeah, that kind of answers my question. So it's like I don't know about where we'd want or not want. I work at Lux.io, and we kind of just like whoever's managing the clusters, which is my team. We have access. We have like we can control the cluster, right? Like that's what we
Mhm.
want to do. We want to fix it when production's having issues, etc. So I'm not looking to make things harder. You know, that's the I'm not looking to make things really difficult on the team, but I would really like this sort of the notion of saying like, look, um, let's say if we wanted to have someone who, let's say, if like I would like someone to join the team who can't really access, let's say, a European cluster, right? Like I don't want them
Mhm.
to be able to access a European cluster's data, the GDPR, etc. Um, depending on where the developer is, then I would want that, and then I would say, okay, so now I need to prevent them from doing this. It would make sense to even disable like a lot of those things, but for just saying like who can do what in terms of tasks, yeah, I don't see that happening. Like if they're an admin, they're an admin. But for
Well,
the search level, I like the idea of saying like these things, like Lucene doesn't have to be the way of storing these entities, of course.
Well, and I mean, we've been using Lucene as the method as the medium for a while. I don't know that we necessarily need to have a change of medium, but the thing that I look at is I say it's really easy to cache um, access rights, like ACLs, to know if you have access or don't to something, if they're uniform and if all the information needed to make the decision is in the URL. So I might advocate strongly for that. Um, but I think, yeah, there's a question of what needs to be permissioned. Um, I don't, I don't envision changing how administrators get access. Right? I don't think anyone wants that process to be more complicated than just saying like you get star on star. Um, but I think for when we do have clusters that have different granularities of information, um, have it making it really crisp what that difference is. Um, and knowable, like an answerable question, other than you know try and perform the query and see if you get a 403. Because I think that's just a bad experience. That then unfortunately is in a number of locations in the product. So that's what I have here. I've got way more documentation. I've got design docs that are up online. If you're interested, please follow up with me. Issue 6181 is the like broad RFC on OpenSearch. Um, and then I've been working on experimental release and prototype, and that's the issue down here. Please feel free to take a look at them, email me or reach out to me on any of these other things. Before I go, any other final questions? Chris, you're a rock star. Thanks for putting that in the chat.
He's quick with those, isn't he?
It's amazing.
Well,
Excellent.
coming on, Peter. We sure appreciate your participation in this. I know it was a last minute request, and it's always nice to see you on here. You know, you're a welcome visit for sure.
Excellent. Well, thanks so much for having me.
Yeah, you bet. Let's see here. What's next on the good old agenda here? It looks like the OpenSearch Events Correlation Engine. Praveen and Subo. So, I don't want to mangle the name too bad. If you could maybe throw me a clue here so I'm not drowning so bad.
Yeah, so today, hi, I am Shubho. So I work as a software development engineer in the security analytics team. I have been working at Amazon for about 2 years now. And I have been working throughout on alerting plugin in OpenSearch and then security analytics plugin in that area actually. So today I will be presenting to you the events correlation engine. Uh, so the idea originally for building a correlation engine actually came from the security analytics perspective, but today I am going to focus on first like how this idea was actually initialized, and then how we actually went on to develop this correlation engine, and finally uh, what what are the opportunities that we see of extending this to core actually. So these are mainly the three aspects that I would like to focus on today. So my first slide is going to focus on the use case, why we actually decided to uh, come up with correlation engine. So in security analytics, we have actually what we try to do is we try to monitor logs from customer infrastructure, and then we actually try to analyze those logs and come up with security findings, and we show these findings and alerts to the end users actually. So if we look into this diagram here, I came up with a very sample and user infrastructure. Maybe they just want to run some kind of a Python application. So there is a Django REST application that is actually running in an application server. And then we have actually this application is running on a Windows machine. And then we have an identity provider, which is actually uh, which is actually uh, which is actually authenticating these APIs, access to these this application APIs, and then this Django application is actually writing communicating with S3 as a database for storing and then retrieving of data. And we also have this VPC flow logs, which is monitoring the network traffic to this EC2 Windows machine. So this is a very simple infrastructure. Maybe it will become much complicated in a real scenario. But just to explain the concept of what correlation is doing. So today, what security analytics without correlation engine, what it would have is, so we define something like this security analytics detectors. So these detectors actually monitor logs for each of these individual individual systems. For example, these S3 access logs are monitored by this S3 access logs detector, application logs detector. So these logs are actually ingested into OpenSearch as OpenSearch indices, or you can imagine as index patterns, or rollover indices, basically. Like every day customer like user keeps on ingesting actually these kind of S3 access logs, application logs, and so on. And once these logs are actually ingested into OpenSearch, stored inside an index or index pattern, then these detectors actually kick in and they monitor these logs regularly at a fixed interval to generate findings, security findings actually. So in this scenario, if you think of this infrastructure, and if you try to simulate a security attack, let's imagine that someone is actually continuously making a call to this to one of the APIs of this application, which is like, say, okay, post customer records.txt. So somebody is actually trying to copy a file, maybe just trying to simulate this. Somebody is trying to copy a sensitive file from S3 actually, and they are continuously getting permission denied error, and they are trying different kinds of username password combinations actually. So these detectors that they are running, so each of these components are going to produce individual logs. For example, S3 is going to say that, okay, file replicate object is S3 status code, I think. So replicate object is permission denied. Actually, from S3 we get this event. From the Django application, we get that, okay, this post call is returning 403 forbidden error. The identity provider is going to say that, okay, there is an invalid username password combination that is being used, and Windows instance is going to say that, okay, this is the host name, this is the Windows host name through which where the call landed, actually, where this REST call actually landed. And subsequently, VPC flow log is going to give the source address of the call and these kind of things, actually. So each of these detectors then generate their individual findings. And now, say I, as a security analyst, I am looking into these findings, and I see that, okay, there is an application finding, application log detector finding, which says that, okay, this particular call is like has a status of 403 forbidden. So now what do I do next? How do I see, like, what is the overall scenario of this attack, basically? Like, what is the actual scope of this attack? So so that is when this correlation engine actually comes into picture, which allows user to say, okay, given this finding, user already sees this finding, given this finding, I can correlate this finding with the correlation engine actually automatically shows the user that, okay, given this finding, this is the nearby finding with which maybe this finding is correlated with, maybe this is another nearby finding with which this finding is correlated with, and so on, actually. So this gives the user an overall view of how actually the entire attack was simulated on this, or was carried out on this infrastructure, basically. So that is with this background of correlation engine. So I would want to come into so how do we do this? How do we correlate this? So these ultimately, this comes down to, okay, the logs are being stored in a particular index. Say the S3 access logs are stored in S3 access logs index. The application logs are stored in application logs index, and what determines that, okay, this particular event in this, or this particular log entry in say in application logs can be correlated with this particular log entry in S3 access logs. So we have this 3 dimension of correlation, which helps us to determine that, okay, these based on this criteria, based on these dimensions, these 2 log entries can be correlated. So these are actually the time window. First is like user configures that, okay, maybe this S3 access log of replicate object permission denied has happened within, say, 5 minutes or within 15 minutes of continuous API calls being made with 403 forbidden status error being returned, actually. So that's the time window. Then the next is the source event indices. I explained already this one. So this could be, generally users have rolling indices. So they use data streams for storing these logs. So that becomes our second dimension that user need to, I will come like how these dimensions are actually configured as part of correlation engine, but this is the second dimension. And the third is actually the correlation rules or queries. So these are actually the rules based on which I can also determine that, okay, this particular event from S3 access log is correlated with this particular event from say application logs. So these are basically the 3 dimensions of correlation based on which the correlation engine actually works. Now one thing I would, so before, I think, jumping onto the actual implementation, I would like to explain the overall architecture of the events correlation engine. So we have this correlation query layer on the, as we see on the right hand side, so which is nothing but which is storing these correlation rules that are actually configured by the user. So and this actually has this REST layer and transport layer, and then this storing in a OpenSearch index itself, actually these queries. And then we have this actual correlation service, which has a REST layer, a transport layer. So REST layer, if an end user would want to look into, like I mentioned, I have a finding, I want to look into the list of correlated findings. So that is when the user from dashboard or directly via the API can call the REST API, REST layer. If a downstream plugin, for example, if security analytics would want to consume this event correlation engine logic, then they would call via the transport layer. So that's the second way to communicate. And then we have this join handler. So how correlation engine actually works is uh, mm, uh, so uh, 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 to explain this join handler, so say we need to understand actually understand the correlation rules, how they look like. So in this case, if we see here, so this is a typical correlation rule which says that, okay, the VPC flow logs are stored in the index VPC underscore flow, and this is the query. This is based on which these are the events which can be actually which are valid for correlation based on this query actually with the Windows logs. And let's assume that that's where the rule actually that's what the rule contains. It doesn't contain the relationship with AD logs or with app logs. It doesn't contain that. So if we look into our diagram here, so what is there is actually from this, so only this relationship is there. Let's assume that only this part of the relationship, the VPC flow log to EC2 Windows mesh instance, this relationship is there. And say this relationship is also configured separately actually, so not part of the same rule. So once the user actually configures this relationship, what would happen is actually each of these log entries are going to be converted into vectors internally, and based on these rules, obviously. So if, for example, these rules, for example, say from the VPC flow log, we get, okay, the destination address is like 4.5.6.7. So that particular VPC flow log is being considered as a log event that can be correlated. And then for Windows, if this clause is made, this query is made actually, so then that particular window event is actually considered for correlation. Now, these events come asynchronously. There is no guarantee that in the order in which these events will actually be ingested. So based on this, we actually classify these events into two categories. We have orphan events. For example, this VPC flow log event maybe came earliest, the first event that got inserted into the index, actually into the VPC flow index. So that becomes an orphan event for us. And then we have this Windows event, which comes in, and we see that, okay, yes, it matches a particular correlation rule. So then we determine that, oh, so once this VPC flow logs event is ingested, we actually create a vector out of it and store it in the vector DB of OpenSearch actually. And then we have this Windows event actually coming in. Once this Windows event coming in, based on these rules, we determine that, okay, this Windows event can be close to the VPC flow log event that actually got inserted earlier. And we create a unique vector out of that Windows event such that it is stored closest to that particular VPC flow event. And subsequently, what I'm trying to explain is actually, so now the VPC flow log event and the Windows event are already stored, and subsequently say there is an app log event that came up. So this app log event now has a particular correlation rule which is matching with the Windows rule, because the Django app is running on a Windows instance. So these two can be easily correlated. So there is a correlation rule which defines this, and based on this, now this app log event is stored closer to the Windows event. So like that, we keep on constructing, we keep on growing this graph over based on these correlation rules. And when, say, user chooses one particular event, actually, for example, they can choose any one. For example, they chooses ADLDAP. Maybe they just saw this particular event, like invalid username password. Then we can actually show, because these relationships are already stored in the graph in form of vectors, obviously. So we can actually show that, okay, this particular event is correlated, is closer to this, is closer to this, is closer to this, is closer to this. So that's how this that's how I mean, even though the user didn't know that all these systems are interlinked with each other, we are able to show to the user that yes, there was an attack which involved all these systems together, and this is the overall view of this of the attack, actually. So a good example of this I can show you here is we were actually simulating an attack on between, say, the VPC logs, the Windows logs, and using the ADLDAP logs. We did not have an application running. So, and as we can see, these are the correlations that get generated. There was also some which says that, okay, S3 and S3, maybe because there was an attempt made to replicate a file twice within a time window. So that's why we see this kind of correlation. And maybe here also we see another interesting correlation which shows that, okay, this attack was carried out twice. So as you can see, Windows ADLDAP network once, and then again another one within a very short time window. That's why these two could not be actually differentiated from each other. So that's why we see this. However, this one happened maybe 4 hours earlier. So that's why this correlation was actually could have been differentiated from these ones. So these are some of the examples of what correlation engine provides as a capability today. Yeah, so I think today, if we look into, if we think in terms of, so any questions so far, actually, before I move forward with the actual implementation? And
Generic question. In the beginning, you showed that there's detectors. So as a user, I would be setting up the detectors first. And then the correlation engine automatically derives the rule. How did the rule get created that you were showing earlier in the JSON? Do I have to create that as well, or
yes,
where's it come
So
from?
today, so today I think so these detectors are in the context of the security analytics plugin, actually. So these detectors, what they do is they run a set of Sigma rules, which are like community contributed security rules, and based on the Sigma rules, we generate actually security findings. And in the security analytics plugin, what we do is we then try to correlate between these security findings, actually. So that's where the context of the detectors come. So when we try to correlate the security findings, obviously the user would need to configure the correlation rule once. Like, okay, I would want to monitor these particular Windows machines, maybe 50 out of 100 machines that I have. These 50 machines are actually interesting for me to monitor. So they specify this kind of queries. They need to specify. We do not automatically derive. And based on this, and maybe say from this application logs perspective, anybody calling this particular API is interesting for the user. So they also configure this as part of their correlation rule configuration. And based on this, these relationships, so once they configure this rule, they do not need to interfere. The system would then automatically consider these rules when these logs come up. Basically, say the application logs come up, or when the Windows logs come up, and then it would automatically generate those correlations. Yes.
So in other like I don't get the benefit of these detectors being triggered around the same amount of time, around the same time, and then the correlation rule being created based on these groups of detectors sort of going off at the same time, or more or less at the same time. Because I
So
mean, when I'm looking at the two, I mean, we already have, like, you could derive the correlation rule from your detectors already, right?
So the detectors, if we think of, so these detectors actually they can only generate findings for, say, S3 access logs, or say for an individual log type. They cannot generate a correlated finding. For
I
example,
know.
they cannot. Yeah,
After they detect, they create the finding and they
they
publish
create
it,
a
right?
finding. They
Yeah,
publish it.
they could,
Yes.
yeah.
Yes.
Then the correlation rules can run against that, like the
Correlation rules can run against that.
which they
Yes.
right. That's what
Yes.
you said earlier. They could
Yes.
automatically also derive the rules based on findings showing up, couldn't they?
Yeah, so there are different mechanisms how they can actually do that. So, for example, so what are these findings? And we have to see, like, okay, what are these findings actually? So these findings actually link a log with a set of security rules actually. So for example, I have an S3 access log, and this S3 access log matched, say, a security rule which says that uh, anything which has status replicate of, sorry, anything which was trying to replicate a file and has got status permission denied, that is actually a security finding for me. So what we can do is, from these findings, so we can actually look into this. So there is a security attack database which actually lists down all the attacks that have happened in the past 10 years or 15 years, and what are the common techniques that have been used to carry out those attacks. For example, say somebody who is calling an API directly may use some other technique also to carry out a similar kind of an attack. So what we also try to do is, based on the security findings, we try to determine, okay, which of those attacks with which we can correlate this particular finding also. And that gives us the scope of generating automatic correlations. But obviously, there are chances that we can get false positives also in doing this automatic correlation. So that's where we came up with this approach of using the correlation rules as well, which allows the user to uh, I would say, to shorten their area of search, where they would want to the space of search, basically, where they would want to find out okay, the most relevant information for them. So these yeah, both sides, both of these things we support today in security analytics. But today, yeah, uh, does that answer your question?
Yeah, it does. Thanks.
Yeah, sure. Yeah, and so for today's discussion is more around like how we can uh, uh, leverage this concept in core also. So today, for example, today OpenSearch supports only searching over an index or index pattern or a data stream actually. So what we would also want to introduce is correlating across these indices or across these data streams based on these correlation rules or queries actually. So that's where we came up with this event correlation engine concept. So the event correlation engine doesn't have this concept of detectors, because that is a security analytics concept. The event correlation engine just tries to correlate events. For example, it will try to correlate a particular log that came from VPC flow with a particular log that came from Windows and so on, and it can show this view to the user. Yeah, and so finally, I would just shortly present what I already explained a little bit about the internal implementation of the correlation engine. So like I mentioned, so these findings or events are actually come in two flavors. They are orphan events or they are correlated events. The first event that came up is an orphan event, and then subsequently the next event that got inserted is actually a correlated with event with F1 with the orphan event. So then we actually store a relationship vector inside the vector database of OpenSearch, and subsequently there is a new event that maybe came up, say for example F4 came up. Then we try to see that, okay, does there already exist correlation? How do we differentiate that, okay, F1 and F2 group is different from the F4 group that came up? So how we do that is actually we rely on time. Most of the times actually, so say when F4 came up, we try to see that, okay, are there already existing relationships that are already there, already present? So then once we see, okay, the F1 and F2 is already present, then we actually go create a new layer inside our graph or in the vector DB actually, and store F4, and subsequently we store F5, and we keep on growing these layers over, so that the distance between them. So for example, if an user actually comes and searches basically that, okay, give me a particular event closer to, for example, F6, give me all the correlations which have happened closer to F6. What we do is we construct a query vector in its corresponding layer, and then we try to see, okay, what are the nearby correlations that have been formed actually. So, and then that is what we return. So we return F4, F5, and F6 are the closest, but not F1 and F2. Obviously, user can get F1 and F2. It is nothing like they cannot get, but they have to. So so they need to provide a parameter. So if they want, okay, I want my say 2 closest neighbors, so then it may give F5 and F6. If they want, say, 3 closest neighbors, it will give F5, F6, F7. If they want 4, then it would go on to extend that to F1 and F2 as well. They also have to increase the time window, and these kind of parameters are there based on which they can.
Sorry to interrupt. We have 2 minutes left.
Yeah, sure. I think so. That is all actually from the implementation perspective. So I would just want to finish off with this is the event correlation engine RFC. You can actually have a look into it. I can also share that as part of this, just to finish off. Yeah. So this is the RFC. This describes the event correlation engine and how it works. The query already I introduced. The high-level design I also mentioned. The join handler, insertion handler. Join handler will join the logs. Insertion handler stores them as vectors, and so on. And then you can actually suggest improvements in this idea. And yeah, the API spec is also there as part of this RFC. And you can also look into some of the implementation that have been done so far. These are the 3 pull requests. And yeah, that is all from my side.
Thank you so much.
Thank you. Amitai, do you have a dad joke for us since we've lost Nate? Amitai, I'll let you step in if you've got one.
No, I don't. That's you know, all my friends are waiting. They're like, this is what I do. I wait for his joke and then I move it on to the next people. You know, it's just, and now I got nothing.
All right.
This is a problem.
So
I can cover us.
Nate, okay.
Oh no, you go for it. Let's hear it.
In honor of Nate, why did the octopus beat the shark in a fight? Because it was well armed.
Ha! That was great.
Well done, Chris.
Well done.
Nice.
I feel like David had one too, if we want to go for two.
I was gonna say, what do you call apple juice? Or yeah, what's another name for apple juice? iPhone chargers. That's all. Students. Thanks,
God.
everyone.
Thank you.
Thanks, y'all.
Catch y'all in the next meeting.